Hello everyone. Good evening. Dear author and invited guests, welcome to technical session 3G. Myself, Richa Shah, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the ninth International Congress on Information and Communication Technology, ICICT 2024, London, UK. The ninth edition of the conference is being organized in a hybrid mode. The physical event was organized in London, UK on the 19th and 20th of February 2024. The virtual event is being held through Zoom today and tomorrow, that is the 21st and 22nd February 2024. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes each for the presentations and 2 minutes for the question and answers. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start, I would like to introduce our session chair. Dr. Sunil Kale, sir, he's working as an associate professor at the Department of Artificial Intelligence and Data Science at Vishwakarma Institute of Information Technology, Pune, Maharashtra, India. He has over 20 years of experience in teaching, and his area of interest lie in artificial intelligence, natural language processing, and text analytics. Sir will be the session chair for today. So, would you like to say anything?
Yes, yes, thanks, Richa, for introducing me. Okay, just Richa told about me everything. I have done PhD in text mining, one of the area of machine learning, and yes, all the best, all participants. Time is very much less, that is 12 to 13 minutes to present you. So try to present the core part of your research. Yes, thank you, Richa, ma'am.
Okay. So now we can start with the presentations. Um, okay, so Mr. Matthew Denson, and he'll be presenting his paper titled Effectively Matching Programming Languages to the Introductory Programming Teaching Paradigm. You may start your presentation, please.
Okay. You can see my screen, correct?
Yes, your screen is visible.
Yeah.
Please start.
Okay, thank you. So my paper title is Effectively Matching Programming Languages to Introductory Programming Teaching Paradigms. I co-authored this paper with a student of mine, Ojoniko Abba. He was an undergraduate student at the time working on this research project. And I'm a faculty member at Murray State University. I'm an associate professor there. And I think we'll go ahead and get started. So this slide outlines our motivation. We're interested in studying the best way to teach introduction to programming classes. And we want to keep in mind that there are many different audiences for learning to program. There are primary school students, secondary school students, university students, and adult learners. And each of these groups learns differently. They have different motivations. They have different mindsets. And they have different levels of understanding. So it could be different depending on the different learner group. And we also understand that there are many different ways to approaches to teaching programming. There are objects late, objects early, visual, structured, and functional approaches. And there are also many different programming languages. There's Java and Python at the university level. Those are probably the two most common nowadays. JavaScript is also very popular. C++ is somewhat popular. For younger students, Scratch is pretty popular. So there are different languages, different learning groups, different approaches. And our goal is not to debate which approach is best or which programming language is best. There's been lots of debate on those two topics for many years. Our goal is to fit the different groups together with the different approaches with the different programming languages. So which programming language is best suited, for example, if we wanted to teach objects early approach to adult learners? And is that different from if we wanted to use a different approach for a different group of learners? So we want to fit together those different approaches and groups of learners and programming languages and figure out what works best. So these are the different approaches I've already listed. And so these are the approaches that we studied. And we do understand that there are other approaches to teaching programming. There are things like peer learning. There's paired programming. There's something called POGLE. I forget what the acronym stands for, but it's very similar to peer-assisted learning. And any of those types of approaches could be combined with the 5 approaches that we have listed here on the screen. For the most part, the 5 approaches that are listed here on the screen are mutually exclusive. You can't do both objects early and objects late, for example. Those two things are diametrically opposed. And a visual programming approach is very different from all of the other 4 as well. So we understand there are other approaches that could be used, but those can be used in conjunction with the 5 that we identified here, which are mostly mutually exclusive. So I'm going to go through each one of these. I'm not going to talk in great detail because we're limited on time, but I'm just going to give a short overview of what each of these approaches is. The objects late approach is basically what it sounds like. Students learn basic control structures like conditionals and loops and procedures before they learn about object-oriented programming. In an objects early approach, students learn about object-oriented concepts either right from the beginning or very early in the process. So they learn what an object is very early, and then they start structuring code in an object-oriented way very early as they're learning to program. The visual programming approach is visual in nature. It can be block-based, it can be drag and drop. So you have a block that represents a loop, you have a block that represents a conditional, you have a block that represents different types of statements, and you put those blocks together to create your program. So you're programming in a very visual way. The structured programming approach is where no actual programming language is used, but things like pseudocode and flowcharts are used. So the point is that you focus on the problem solving and the development of algorithms without getting bogged down into, excuse me, without getting bogged down in the details of the syntax for a particular language. And in the functional programming approach, we write programs basically using functions. Programs are written by creating and calling functions. That's the functional programming paradigm. Functional programming is declarative rather than an imperative. So you're not telling the computer what to do statement by statement by statement. Instead, we're declaring lists typically, and then how to manipulate those lists through functions. And functions are treated as first-class citizens. So you can pass a function as a parameter to another function. You can return a function from a function, just like any other data type. So that's the functional programming approach. Okay, so this was the basic methodology for our research. It's centered around a survey. We surveyed instructors at universities, and we surveyed working software professionals. And we distributed the survey in both a broadcast way and a targeted way. We used all of our contacts that we could to reach out to working professionals, and we asked them also to distribute it among their peers. So we distributed that in a targeted way like that. We also used the U.S. News and World Report rankings, which is one of the most well-known ranking system in the U.S. for universities. And they categorize their universities into different categories. They have regional universities and national universities and specialized universities. So we actually chose, and we had a procedure for doing this in a repeatable way. We chose universities from each category to have a wide range of samples and types of samples, variation in our samples, and we surveyed those particular professors at those universities. And basically for each, in the survey, we asked for each age group what language is best for each approach. That was getting right to the root of what we're trying to find out. The languages that we included as options explicitly on the survey included Java, Python, C++, Scratch, Blockly, Haskell, Scheme, and pseudocode. And that was probably the most difficult thing to figure out when we designed the survey, was which languages to include. And we understand that by including specific languages, we're automatically introducing bias. So we wanted to avoid bias as much as possible. So we picked a wide range of languages, ones that are commonly used in introduction to programming at all different levels. And also we wanted to have representation from each of the different approaches, because there are some obvious relationships between approaches and some languages. So we tried to pick a wide range of languages to be representative. And we also provided an option for open-ended responses. So respondents to the survey could give the other opinions, other languages, in addition to those that were listed. So this is these are the results in a nutshell. In our paper, we actually dive into the details. We do statistical analysis for each different approach, for each different group, for each different learning group. But this is the overall summary of results. So these are the different approaches: visual, structured, objects late, objects early, and functional. These are the different learner groups: primary school, secondary, university, and adult. And these are the languages that were recommended for each of those combinations. And we understand this isn't earth-shattering, this research, but we do think that it's a good start to figuring out what approaches are best for which groups and which languages are best for each of those approaches. So there are a couple of things here that kind of stand out as unusual. For the structured programming approach, pseudocode was most popular for primary school students and university students, while Python ended up being the most popular choice for secondary school and adult learners. And I'm not really sure why we see that sort of discrepancy, but that's kind of an interesting result. For objects early in primary school, there was a tie for the most popular between Java and Python. For older learner groups, Java was the most popular for objects early. Python was the most popular for objects late. Scratch was the most popular for visual programming, and Scheme was the most popular for functional. So there really isn't a whole lot of surprises here. Like I said, it's not earth-shattering results, but it's still interesting nonetheless. And we also did a
sorry to interrupt, Matthew, but then
yes.
you'll have to wrap up your session within the next couple of minutes because 10 minutes are over.
Okay, I have one slide left, and I'll wrap it up. We
Yes,
also
sir.
did an analysis. We also did an analysis on the open-ended questions, and we found that the most common word that was responded in the open-ended question was functional. So a lot of people had opinions, perhaps, on the functional programming approach. The most common word pair was Visual Basic, and Visual Basic was not a language that we explicitly listed as an option in our survey. So if we did future research, perhaps we would include Visual Basic in our survey. Other languages that were commonly mentioned were Visual Basic, JavaScript, and Clojure. So again, those were popular languages that people brought up on their own. So if we did this survey again, we would probably include those languages to be more fully represented. Some other conclusions based on the open-ended analysis. Visual Basic, we found, was a popular language for the university group. But we don't know, based on the responses that were given, which groups, which approaches that would apply to. And JavaScript was popular for multiple student groups, and Clojure Functional was mentioned frequently. So, of course, Clojure is a functional programming language. So perhaps perhaps Clojure would have been a more popular language choice for functional programming if we had included it explicitly on the survey. So that wraps up my prepared portion of the presentation. If you guys have questions, I'll gladly answer questions.
Yeah, I have questions. Yeah.
Okay.
Yeah. Thank you for your presentation. I think it is very interesting to me. I have a question. Have you ever considered about the in your summary result, right? I see that there is no C and C++, right? So do you think that the C and C++ now is not used as common?
Yeah, I think nowadays at the university level anyway, that's what I know the most about. Python and Java are by far the most popular languages taught in introductory programming. I don't, and C and C++ have both fallen in popularity in recent years. So yeah, I think that people see Java and Python as a simpler. Those are both general purpose languages, and they're maybe a bit simpler than C and C++. So I think they're not quite as popular anymore. We did include C++ as an explicit option in the survey, but it didn't show up anywhere as the most popular language.
So do you think that in professional programming, nowadays they use Python? They use more Python than C++?
Yes, I think that's definitely true. There are other surveys that are done periodically. I think there are some that are done annually to find what the most popular languages are used in industry. And I think Python and Java and JavaScript, those three have all surpassed C++ in recent years.
Yes, thank you. Yeah.
Thank you.
Yes, well, Matthew, just one question from my side. Okay, so what population, that is, what is the statistics or the size of populations was there for primary school students, secondary students, university students, and adults? Do you have such a table or summary of statistics that regarding to the population considered count I'm asking about?
That's a good question. We did not, that was not within the scope of our study, but that is an interesting question, and I would be interested to know that as well. Maybe I'll do that as some follow-up research. But I don't know about the population for each of these groups, how large those populations are.
Because just as per me, that is also important because we are concluding something that is based on the number of people's opinions. Okay.
Yes. Are you
Okay,
talking
well,
about the population of the
uh,
survey respondents, or are you talking about the population of learners?
population, that is the number of peoples that you surveyed regarding with
Oh, the
respect to the
survey.
primary school students, secondary school students, university and adults. What
Yeah.
count of these peoples you provided this survey form?
Yes, we didn't survey the students. We
Okay.
surveyed working software development professionals and university instructors. Those are the two groups that we surveyed, and we do have statistics on the survey respondents in our paper. I didn't include it in the presentation, but that information is available in the paper. I thought you were talking about the population of learners, not the population of survey respondents.
Yeah, because it's opinion from them, right?
Yes.
Okay, fine, Matthew.
So now we can move on to the next presentation.
All right, thank you.
Yes, thank you. Sir, are you ready now?
Yeah, I'm ready now. Yeah.
Okay, please could you start your presentation?
Yes. So can you see my screen?
Yes, it's visible.
Yeah. Uh, so Hi everyone. So my name is Han. So my presentation topic is about assembly moving object on conveyor using computer vision. And let's have a look at the some current status. Okay. I think that all of you already heard about the assembly an object, right? And here in the I have the two movie on the screen, right? On the left hand side is the a man, right? He's assembly an object on the moving conveyor, right? And now currently this is performed by human, and right hand side is performed by robot. But you can see that it's go on a stop and go mode. That means the object have to stop on the conveyor, and then robot performing the assembly task. And the problem come here is in the stop and go mode. The conveyor downtime and accumulate and lengthen the entire assembly process. And about the flexibility unsuitable for small scale, and also sometimes the object on the conveyor they are lying in random positions, right, as well as orientation. So that means we need an automatic guided system in these situations. And as the first stage of the development, we develop a system so on the screen, and we are doing experiment on this system. Our system consists of one industrial robot. We call this native robot, and a conveyor is moving, and we attach a camera at the end effector of the robot, and we use the normal computer to program. And an object here is the cube object here, and this is the assembly object. We will put the small object into two holes on the cube, on the cube here. Okay, and the side here you can see that the whole cube, small cube here is about 29, and 29, and the whole here is about 30 here. You can see that the precision is very high, just about 1 millimeter. And the procedure is so on the screen. First, we will use something called image processing. First, we use color filter to extract the object on the conveyor, and then we do some filter we call morphological opening, closing, to remove the noise, as so on the on the screen. And then we use the image processing called fine contour area to detect the black hole on the object, and then we calculate the centric coordinate and the orientation of the hole. Okay. Yeah. And in the computer vision, in the last slide, in the previous slide, you just see about the image processing, and we just have the coordinate in image coordinate. We call it pixel coordinate, and we for the robot to operate or to assemble an object, we need to change the pixel coordinate to the real world coordinate or robot coordinate. It consists of two steps. First, we do the camera calibration to change the pixel coordinate to the camera coordinate. And then here, this is the camera calibration process. We will take many pictures on the screen, about 20 images, and then we apply the Yang method. It's a very famous method for camera calibration, and it's integrated in the software, we put in the MATLAB software. And then after that, we will have the transformation matrix from image coordinate to the camera coordinate. And then the next step is we have to translate the camera coordinate to the robot coordinate. And on the right hand side here, we use a chest, a board like this here. And then the procedure is that we will take the, we will move the robot. We will move robot by using this button. We move manually by using this button to 3 points. First point for the origin, the second point on the X coordinate, and the third point on the Y coordinates. And then we have the transformation matrix as shown in the slide. Okay, and here is the some video demos on our experiment.
So sorry to interrupt, but 10 minutes are almost over. So you'll have to wrap up, please.
Yes. Okay, and here is our experiment. You can see that it is the cube moving on the conveyor, and then the robot will use the camera integrated at the end effector to detect, and then detect the object, and then assembly the object on his. You can see that an object is pushed randomly on the conveyor. And here we just use C and C++ for programming. Yeah. And the conclusion, the advantage of the technique is we can use the visual system to detect an object and track the object when it's moving. And the robot can pick up small specimen and then track the big object, and then implement the assembly task very fast. And disadvantage, the shape of object now is a little simple, and the speed of the conveyor is still slow. We need to make it faster. Okay, and in our future development here, you can see that we will assembly a 3D object, a 3D object moving on the conveyor. This is our next step 2. Yeah, thank you for your attention. Yes, and please have any questions. Yeah.
Yes, well, which color filter is used for detection of the object?
Yeah, can you say again? Yeah.
Which color filter is used actually? What is color filter? Go on second slide actually.
Second.
One more back. Next. And one more next.
Yeah.
Yes, on this,
Yeah.
that color filter that you have utilized just before this camera calibration.
Yeah. About the camera calibration, is follow procedure that we take the 22 image, something like this, and then we will take 4 corner of the image. 4 corner. It's simple. Can you see my mouse on the screen? Yeah, I will take the 4 point on the image. 4 point. Yeah, on each image I will take 4 point, and then I can and after that it will save in the text file for the MATLAB, and then the MATLAB software will extract, and then it will calculate the transformation matrix from the
Okay.
pixel coordinate. Yeah.
Okay. Yeah. So while experimenting, how much time it take to detect the object?
Yeah. To detect the object is very fast here, and it's about I also as already summarized on the in my paper. Yeah. Let me see. For detect an object, it just take about 100 milliseconds. Just
Okay.
about 100 milliseconds. Yeah.
Okay. Fine.
Yeah. Yeah. Thank you.
Fine. Good. That's it from my side.
Okay, thank you, sir. Now we can move on to the next presentations. Sir, are you ready now? No problem. We can move on to the next presentation, and when sir will be ready, we will come. Um,
So hello again, sorry about before. I should be able to share my screen now. So let me
okay, yeah, we can start with the
currently you have
presentation.
all right. I think you have, yeah, perfect. So now you should be able to see my screen.
Yes.
So hello everyone, hello again, sorry about before. So I'm going to present our paper, which is called Comparative Evaluation of Anomaly Detection Methods for Fraud Detection in Online Credit Card Payments. So this work was done in collaboration with my fellow colleagues that are written on the screen. I myself am Hugo Timonier, a final year PhD student at Centrale Supélec. So to begin with, maybe let me put a bit of context. So why is fraud detection important, and why are banks trying to fight against it? Because, well, it has an estimated cost of around $29 billion in 2021, and current trend shows that it keeps increasing, although detecting systems are getting more and more complicated and better at the task, but there are more frauds coming in every year. And until quite recently, banks and financial institutions were actually relying on what we call rule-based systems, which are quite simple and which are actually quite nice because they're interpretable in the sense that they're understandable by anyone. So it takes the form of something like if the amounts exceed the sums threshold, and if the payment was made in some location at a precise time in such a currency, then it's a fraud. In that case, you can understand it easily, but the problem is it's not so powerful, and it requires like costly expert knowledge to be constructed. So it's kind of a problem. That's why, given the recent successes of machine learning approaches in many tasks on unstructured and structured data, banks have turned to those approaches to try and tackle the question of detecting frauds on credit card payments. So the application of fraud detection is actually quite different from standard applications you can find in machine learning, in the sense that it has two characteristics. First, what we call imbalance learning. If you're familiar with machine learning, you probably know that you learn from a training set to detect the frauds within the data set. And usually when you do that, you have a balanced data set, which is comprised of of an equal number approximately of samples belonging to each class. But as you may imagine, in the case of fraud detection, you have very few frauds in comparison to the number of legit payments. And the second problem is the distribution shift. The fact that the distribution that generated the training set is somewhat sometimes different from the one that generated the test set. This is because, well, let's say payments and the way you consume changes over time, and new types of frauds tend to arrive with time. So given these two characteristics, there is one class of machine learning algorithm that appear to be quite relevant to solve this task, which is anomaly detection methods. So I'm just going to briefly explain what anomaly detection is. Just to make sure that everyone is on the same page. So if you're familiar with machine learning, you probably know what binary classification consists in the supervised approach. So usually you have a training set which is composed of samples xi with its label being for payments. Xi would represent its features, the amount, the location, this type of things, and yi simply denotes to which class the sample belongs, so whether the payment is a fraud or is late. And you're simply going to try to learn a mapping from the feature space, so X, to the label space. So in other words, you're simply going to try to infer from the characteristics of the payment whether this payment is a fraud or not. And this is the standard supervised approach. And in the anomaly detection approach, in the supervised anomaly detection approach, you somewhat change the way we approach things. This time, you're simply going to consider a training set, which is only composed of one class, being you're not going to consider a training set which is composed of samples that are normal and or legates and samples that are frauds. You're only going to consider the majority class, being here the legate payments. And this time you're going to try to characterize the distribution. And you're going to consider that samples that actually do not fit so well this distribution are likely to be anomalies, being in our case, they're likely to be frauds. So frauds are in a way defined in opposition to what legate or normal payments are. So here is a simple illustration. So here, this would be the standard supervised setup where you're simply going to learn a decision frontier using the normal samples in blue and in orange, the fraud payments. You're going to learn the decision frontier in such a way. So first thing to notice here is that we are somewhat having a kind of balanced situation where we have an equal number of samples in the two classes, and this is not the case in our situation. It's harder when you have fewer samples of one class. And another problem would occur if you have some anomalies or some frauds which you've never seen before. So the purple ones which appear at the top left would not be a problem, but let's say you have new types of frauds that arrive at the top right, that would be a problem. Now, in the case of anomaly detection, this time you're only focusing on one type of samples, being the normal class, and you're simply going to learn a decision frontier. Here, there is going to be, let's say, the support of the distribution. And once you've learned the support of the distribution, you're simply going to consider that all samples that fall outside of the support are going to be anomalies. So you define them in opposition to what normal samples are. And here, even though you had samples in your training set which you excluded for learning this decision frontier, and other samples, other fraud samples which you had never seen, you would be able to try to identify both. So there are mostly three types of approaches to anomaly detection. So to be quick, there is one class classification, reconstruction-based methods, and also self-supervised methods. So the experiments which we conducted simply consist in comparing anomaly detection methods to what are considered to be the go-to methods for tabular data, as we have here, which are gradient-boosted decision trees, which is a famous approach in machine learning. If you're familiar with Kaggle, you probably have seen a lot of models working well, which are XGBoost or LightGBM. And we're actually going to experiment on a real-life credit card payment dataset, which was made available to us by a large French bank. So in short, our data set is comprised of the following, has the following characteristics. So we have around 500 million payments. We have frauds that are that represent less than 1% of the payments. We have not approximately, but we have precisely 145 features. So there are raw features, which are simply the amount, the currency, this type of features. And we also have features which we computed, such as rolling sums or rolling means. And a thing important to notice here is that we have actually two time periods which we can construct in our data set. We have payments which were made in the 2018-2019 period and payments that were made in the 2022-2021 periods. Another thing to notice is that we're actually going to focus on only two countries, which I cannot name due to confidentiality of our data set.
Sorry to interrupt, but 10 minutes are over, so you'll have to wrap up.
I have seven minutes on my clock, I suppose.
Sorry? No, you can continue.
Yeah, thanks. So yeah, we are going to focus on only two countries, country A and country B. And as you probably know, between the 2018 and 2020 period, there was something that happened, which is COVID. So we may expect a big distribution shift, being the fact that consumption and fraud behaviors may have changed in between the two. So this is something that we check. We check whether using TSNE and UMAP, which are ways to map multidimensional data to two-dimensional data to simply plot it and see if there is any overlap. No overlap would mean that there is actually a distribution shift between the two periods, and this is what we observe. We do observe that there is actually distribution shift. So this would be something that we could use in our analysis. So the experiment simply consists in training our anomaly detection methods and gradient boosted decision trees on a training set, which is only composed of payments which were made in the 2018-2019 periods. And we simply test it afterwards on a 2018 test set and a 2020 and the whole 2021 time period. And we compare this method using three metrics, so DI-ROC, DI-UPRC, and F1 scores, which are metrics which are usually used in the literature. And we expect to see a decline in the performance for all models between the two periods. So this is the table where we actually show the average results over 10 different data splits on our data sets. So we have on the first line, the light GBM, which is an implementation of gradient boosted decision trees, and all the other models listed afterwards are simply anomaly detection models. And we actually observe a big gap, a sizable gap between the metrics, which is obtained by those gradient boosted decision trees methods, which obtain the highest metric for all situations and all metrics. And this is somewhat unexpected, since we expected anomaly detection methods to actually work better than what we observe here. And second thing to notice is that we actually have a severe decline between the 2018 and 2020 period, which is something we expected, but as well not in that extent. So to conclude, while a priori we expected anomaly detection method to be good alternatives to supervised classification, when confronted to our real-life credit card data sets, we do not find such results. And maybe our work calls for further experimentations on other data sets than ours, because unfortunately the only available public data set, which is the one on Kaggle, actually is somewhat too easy to train models, since you can obtain very high metrics, which are not what you obtain in real life credit card data sets. So thank you for your attention. And if you're interested in anomaly detection, just check our other papers here. Thank you.
Yes, well, one question.
Yeah, sure.
Yes, 145 features was there in your data set, and one that you have extracted, that is rolling mean, right?
Yep.
Yes, apart from that, any other feature you extracted?
We had rolling mean, rolling sums, but across different types of time periods and different type of running means. One type of running mean would be the average payments you made with this merchant over the last week, over the last months, over the last 24 hours, this type of features, for example.
So this input is in a time series data was there, right? These features which were used were actually a way to flatten the data in a way not to use time series data. Yeah. Oh. Okay. How light GBM works?
How does light GBM work?
Uh-huh.
It's a boosting method, so it's I don't know if you're familiar with boosting methods, but it's you simply learn weak learners iteratively, and at each iteration you focus on the previous weak learners predictions on the samples which were wrongly predicted by the weak learners, and that's a way to account for imbalance, since the hardest samples are going to be the main focus of the next weak learner at the next iteration. That is how light GBM works.
In dataset, there was any samples that is regarding to not fraud transactions?
Sorry?
In dataset, all samples are with the fraud transactions, or is there any non-fraud transaction samples was there?
So I'm not sure I got your question right, but in the training set which we used for gradient boosted decision trees, we had approximately 1% of the data set which were frauds, and for anomaly detection methods, we used the same training set apart from the frauds which we excluded for training the anomaly detection methods.
Okay, thanks. That's it from my side.
Thank you.
So moving on to the next presentations. Um, Sir, are you available? Hello. Will you be able to present right now? Okay, so now moving on to the next presentation, I'd like to call Mr. Atikar Rahman for the paper titled Understanding Blockchain Technology and its Application in the Emerging FinTech Industry.
Well, thank you very much for the opportunity. Let me share my screen. I hope my screen is visible to all.
Yes, sir, it's visible.
Okay, so a little of introduction of mine. My name is Atikar Rahman. I come from India. I have been working in Paris from last 5 years, and it's my last year of as a PhD scholar. I'm a blockchain engineer. So this my paper is all about understanding blockchain and its application in the emerging fintech industry. I have written this paper with the help of my thesis director and assistant director, Mr. Karim Elia Farwa and Amo David. So let's begin. So it would be better if we first understand that what is blockchain. So a very brief intro, it's a decentralized ledger technology that records transaction across a distributed network of computers. So every transaction is being recorded inside a block in the form of hash and pair, and this is normally is linked to the last block which was made. The first block inside the blockchain is known as Genesis. So coming forward, types of blockchain. So first we have is like public blockchain. These type of blockchain are those in which anybody can come and participate. For example, like Bitcoin, if you want to purchase, you can just go ahead and purchase it. You do not need any authorization to enter. The second come is private blockchain. In this private blockchain, normally, for example, if I have a platform and I want only some participants to come, it's not public. So first, I need to give you the authority, the permission to participate in the private blockchain. Then only you will be able to operate inside the blockchain network. Now, the third one, which comes is custodian blockchain. It is normally a semi-decentralized network where it's a private blockchain. It has a decentralized ledger, but it's been, I should say, governed by a particular authority. They are the governance among the participants members. So moving forward, let's read about the principles of blockchain. So first thing is decentralized. When we say decentralized, it means that there is no single authority which controls the whole application or the whole network. Temporal resistant, it means that no alteration can be made once an event is recorded or a transaction is made for reference. Secure transactions, it's a cryptographic algorithms to ensure the security of transaction. So the chances of fraud or any case of misuse or hacking, it's almost next to zero. It's an immutable. It means like, yes, it's ensuring once a transaction is recorded, it cannot be changed. Peer-to-peer network. It operates in peer-to-peer network where transactions are verified and recorded by the network participants. By peer-to-peer here, it can be, for example, there are 5 computers or 5 people 5 computers connected to each other. So every computer in that network is a peer. So presently we have a myth that applications are just blockchain is just bonded to the blockchain crypto applications like Bitcoin or Ethereum. But normally, if we see this is not the case, for the example, presently many fintechs and healthcares have adapted blockchain because of its, I should say, immutability and the power of trust it gives. The future impact, yes, decentralization is today's need. And I should say that many of the applications has already been migrated to the blockchain. So how does the blockchain work? Blockchain operates through a decentralized network of computer nodes, like I have explained before. For example, if there are 5 computers connected to each other, so they will all operate through the nodes. There is no one single authority who can make the decision by its own. All the transactions are being grouped in blocks, which contains a hash pair key. There are some consensus mechanisms which we are going to study later in the presentation of this paper. Once the transaction has been verified, then they are added to the ledger, creating an immutable record. These distributed ledger technology offers transparency, security, and resistance to a tampering, as altering data require consensus from the majority of nodes. So as we have been speaking, if the transaction is recorded in the blockchain, any information inside the block cannot be tampered. The reason why is so, because it's normally a screenshot. Once it is taken, it cannot be tampered. So coming upon to consensus mechanism, normally there are 2 type of consensus mechanism. One is proof of work, another one is proof of stake. Proof of work is something which has been adopted by Bitcoin. It is like when the miners, they mine to create a new block. They have a number called nodes, which requires the, I should say, transaction information, and they need to match the node with that transaction information to create a hash pair key. And then that hash pair key is to be accepted by the other member of the nodes to complete a transaction. The other one is POS, that is proof of stake. It has been adopted by the Ethereum. It is normally when it is not mining but validating. It is when the nodes itself, they choose one of the node to do validation. The selection process totally depends upon the stake, that how much Ethereum or ethers a node have. So now let's see what can be more cases of blockchain apart from the cryptocurrencies. For example, let's see how a payment or how a fintech can take advantage from blockchain. So first step, let's see cross-border payments. Blockchain enables fast, secure, and cost-effective cross-borders transaction, eliminating intermediaries, reducing transaction fee, and minimizing settlement times. It means that with the help of blockchain, we do not need to go to the bank. We can make a transaction into a personal wallet without any use of any third party. Thus, this can help in reduction of the intermediary cost, which can be reduced sometime. Digital identity verification. Blockchain-based identity management system can provide individuals with secure, immutable digital identities, enabling a streamlined verification process for various online services. Like we should, this is normally in a private blockchain. When a person has to enter, then we give them a certification, which is called a digital identity. So if the person has a certification, can only join our network. Cryptocurrency trading. Blockchain facilitates the trading of cryptocurrencies on decentralized exchange, offering transparency, security, and efficiency transaction without relying on traditional financial intermediaries. Peer-to-peer lending. Blockchain platform enables peer-to-peer lending without the need for traditional financial institution, allowing borrowers and lenders to interact directly, reducing costs and increasing accessibility to credit. Smart contract. Normally, a smart contract is a digital way of writing the contract between the two or multiple person. And thus, it's a very important part because it contains all the norms, rules, and regulations according to which a transaction or an event can be passed. Proof of concept. If proof of concept is basically to see whether the application in which you want to implement blockchain is feasible or not. So normally in this part, we call minimum viable product, MVP. We need to, we create an MVP to validate the technical and the practical aspects of the idea. For example, in the fintech industry, a POC might entail building a decentralized ledger platform aimed at improving loan processing efficiency, enhancing security measure, and reducing operational costs. POCs are served as a crucial step in evaluating the viability of blockchain and applications before committing to full-scale development. Implementation of blockchain. So first, we need to determine the use case. In what use case we want to implement the blockchain and which modules needed. Now we need to create a POC. Now we need to create an MVP, sorry, to see how this blockchain, if we are implementing, how it is feasible and how benefit it can be. And after that, we need to see what consensus protocol which we want to use, which can be, it is necessary because consensus mechanism ensure synchronized node agreement, consider factors such as scalability, sustainability, and security. Options include proof of work, proof of concept, and Byzantine fault tolerance. Byzantine fault tolerance is normally it's an algorithm which is used to fight any of the faulty nodes. For example, our proof of, what should I say, the consensus mechanism is needed to pass a transaction in 60%, and we are having 50 nodes.
So
So
just a gentle reminder, 10 minutes are done, you need to wrap up.
thank you very much. Hyperledger fabric. So Hyperledger fabric is basically a distribution of the blockchain. It's a decentralized ledger where every transaction or every event is recorded. Working of Hyperledger fabric. It is normally, it creates a proposal which it gives to the peer members or the nodes. And after that, the one who and makes the transaction endorses the peer and then get verified with the other peer, other members on the network. So this is the architecture of the Hyperledger, which we are going to implement inside of fintech. So normally, if you can see at the right side, we have two layers. First is like Hyperledger Fabric, adding services. This is normally what AWS has in the managed blockchain. Inside that, we have Fabric Certificate Authority. So this will allow, this will be given to the members who wants to join the network. Then we have peer nodes. At the right side, we see VPC endpoints. So normally this is the application APIs through which we can connect. And the most talk of today's world is the carbon emission. I believe that the blockchain can help in tracing the footprints of carbon emission, and it can really help to, I should say, to control and to benefit the environment, and can be taken as very eco-friendly. Thank you very much. Sorry, I have to rush. Any questions, please?
Yes, actually no question. It was a study, right? So
Sorry?
it was a study paper, right?
Yes.
So with respect to the application, or is any comparative study you have done?
Normally, this is something which I have implemented.
You implemented. Which use case you implemented?
An investment platform.
Okay, so there is any experimentation and results slide.
Yes, like we implemented this blockchain inside our application. So we have used Hyperledger Fabric inside that. So we have our client, it's a closed platform.
Okay.
So we have our clients, they do pass orders, and the clients they are institutes, so normally they are big orders. So for that, they needed something which can be traced and which uh, is very transparent to them.
Okay.
So this was what came on board. And the other thing is, for example, last year we passed an order of 40 million.
Mhm.
So if there would have been no blockchain and if there would have been a charge of 2% on the bank fee, it would have cost a lot. But with us, it was free of charge. So yeah.
Okay. Okay. Fine.
Any other questions, please?
Yes, I think no question.
Thank you very much.
Moving on to the next presentation now. Sir, are you ready now? Mr. Mohammad Bamakara, are you ready, sir, for your presentation?
Yeah, I'm ready.
Okay, you start the presentation, please.
Sure, just give me 1 minute.
Sir, are you presenting?
Yeah, I'm just opening the PowerPoint.
Okay.
Okay, can you repeat the power presentation?
Yes, it's visible.
All right. So, yeah, so our topic or our article actually talks about the use of blockchain and electronic voting or voting systems in general. And it was made possible due to me and my team who were with me, and or colleagues that were with me actually. So we're gonna dive into the actual topic right now. So we'll be talking about few things. So we'll talk about an introduction, we'll define some technical definitions, and why should we actually use blockchain and like e-voting or voting systems in general. We want to also tackle the problem that we saw and we wanted to tackle or solve. We also would like to show related works, other articles that have done similar work to ours. We would also show some proposed approaches, diagrams, and then we'll talk about how could an initial implementation be implemented. We'll talk about like an introduction about what blockchain is. Blockchain basically is a decentralized database. It is used to enhance integrity, reduce fraud. It's transparent and it offers a lot of security when used. In our case, it, it will be used for authentic votes, basically to authenticate votes or address anonymity concerns when voting. Basically, when you vote, you don't want to actually be known, or you don't want to be like seen. Basically, also it can provide speed. It's very fast and can provide privacy as well for anyone who uses the blockchain. So as we discussed about the blockchain, it's a decentralized, it's secure, it's transparent, and it's a distributed ledger over nodes, like a connected network, basically. It utilizes cryptography uh, to ensure integrity and prevent manipulation. It eliminates the need for like any outside entity or like a centralized basically entity to control everything. Basically, it's the people who control everything that is going around in the network. Exactly. So basically if one node is basically like trying to cheat the others could actually potentially know, or other people could potentially know. This is why like it's a trusted network basically, or it depends on the trust of multiple people. So we'll talk about some technical stuff. So for example, there's something called consensus in blockchain, basically ways of verifying basically, or ways of mining basically, and one of them is a proof of work, where you select one node to create a new block by having like participating nodes solve a cryptographic puzzle. Basically, any node that could solve like the cryptographic puzzle first would actually earn the right for that block and could publish that block. In proof of work, it's basically computationally intense. It takes a lot of computational power. However, um, it can create fairness. Basically, everyone has like somewhat of an equal chance of competing with each other. The other one is proof of stake. Basically, you can select a node or a miner, basically, depending on the computational power that they have, or based on the cryptographic currency that they hold. In terms of energy efficiency, it's better than proof of stake, proof of work, basically, and it somewhat has the same like considerable computation as well. It's relatively fast. And electronic voting is just voting electronically. Basically, it provides like a easier way for people to vote, and using blockchain, it enhances that security, transparency, and reduces the risk of fraud and errors. Yeah, and it can also like save a lot of time and effort and money as well when used. Okay, why blockchain for e-voting? Since everything is now online, basically, uh, we need to be more secure. We need to have more transparency. We need to have more privacy as well. So basically, using blockchain for almost any electronic thing is actually very beneficial. It's still somewhat like a new topic. It's always improving. It's always becoming better and better. It's pretty nice to use. It's pretty good to use. So the thing that we wanted to address, which is basically wanted to address security and transparency, especially when it comes to like fraud voting or fraud stuff. At the moment, when we looked at things, fraud voting is like a small percentage in some areas. However, in other areas, votes are basically being manipulated. And the use of blockchain and having like not like one centralized entity controlling everything could solve this issue basically and build up trust. So this is the related work. For example, we've looked over a few other pages and we checked the if they use blockchain, they used if they didn't use blockchain, or what technologies did they use. Because like in our paper, especially, we wanted to basically go for a hybrid approach using centralized database and decentralized database to solve this fraud issue. And so we can actually see like a lot of the papers that are out there do not use the concept of centralized database. What they do, of course, use blockchain. And the technologies that are most often used are smart contracts, web applications, and like certain framework. And the most commonly used platform is Ethereum. There is one paper exactly, which is called an e-voting system based on blockchain and ring signature, which uses both centralized and decentralized database. However, the way that they use centralized database is not related to, or it's mostly just for the web itself, for storing and viewing information. And most of the consensus that's being used is mostly proof of work if they're using Ethereum, and there's a chance that you can also use proof of stake when using Ethereum platform. So our proposed approach, basically, we want to like create this transparency. We want to combat the fraud votes, basically, that could arise later on in the future as well, using both centralized and decentralized database. Both of them would track votes in different ways, basically, and you can later on check like if the votes actually match up, then you would have an idea if there's like fraud votes running or going around in the voting process. So you initially voters are basically authenticated through ID or biometric scans if there's an actual center for voting. They would actually receive an anonymous ID for their vote, which would be sent to the database and not the database to the blockchain and stored there. Usually, the information that will be stored in the centralized database is just general information about the voter, and then in the blockchain itself, it will store who this person voted for, basically. But there won't be like a link between like this person and the vote that's being casted in the blockchain itself. So here's like a figure that we made basically to analyze basically the blockchain e-voting life cycle if there's a voting center basically. So a person would come, they would go to the state voting center, they would basically check if they're eligible or not. Afterwards, if they're eligible, they can go and vote basically. And their information.
Sorry to interrupt, sir,
Yeah,
but 10 minutes are over. Please, could you wrap up the session?
yeah, sure. After basically the person votes, uh, they can actually cast their votes electronically or through a device, basically, which is stored later on in the blockchain, and then it goes through the process of being mined and then reviewed later to see if there's fraud present. There's a sequence diagram which states like how and details how things things are basically going. It goes from the voter staff voting system central to the centralized database. What happens to the what happens to the transaction when it goes to like the smart contract, to the nodes, to the mining process, to the blockchain, and then later on it is used to be viewed in the websites and what. Here's like a general idea of mining in general. So miners would compute the hash, and if the hash value is lower than the actual original hash value of the block, then it's kind of a valid transaction and it's stored in the block. And for the initial implementation, usually like for testing purposes, you could use these three tools, which are Ganache GUI, MetaMask, and Remix, concurrently to initiate transactions, to store transaction, and to create smart contracts as well. So the Ganache GUI stores the transaction or the transactions. Basically, MetaMask is used for the currency, movement of currencies, and between one account to another. And Remix is used for creating smart contracts that could automate the process in the blockchain, basically. And that's kind of it. Questions?
Yes, well, in your proposed architecture, whatever you proposed, in that you told that centralized and decentralized database both you are storing, right?
Yeah.
Yeah. Apart from that, what is in your system, in your proposed system, compared to the existing literature, comparing to the existing work or existing system which are available, apart from these two, both are there in your proposed work. Apart from that, what other core difference compared to the previous or existing?
Oh, okay. So there's usually not a lot of differences between like blockchain systems, since they usually use like the same somewhat similar platforms, or they can go for like a private uh, blockchain approach, basically. However, the key differences are on the method that you want to actually implement, and also like when it comes to smart contracts. So the smart contracts also plays another role on how the blockchain itself is going to be processed in terms of security, in terms of automation, in terms of other stuff as well. But for our purpose, or for our thing, is we wanted to combine not only blockchain, we wanted to apply traditional like traditional databases with blockchain in order to achieve something, in order to achieve a better security, basically.
Okay, well, in initial implementation, what you implemented
Again?
in initial implementation slide just before to this, you mentioned things. Actually, what you have implemented.
So for the
You
initial phase, for the initial phase, we kind of talked about like what tools we can use, basically for testing purposes. We've used these tools for testing. However, we haven't went full scale, or we haven't gone too deep into the topic yet. And we're hopefully for future papers and whatnot, we would actually go and implement our idea, see what works, what's missing, and improve upon that as well.
That's fine. Actually, the slide title was that is implementation. So I thought some implementation was there.
Here or before?
Yes.
Yeah.
Yeah. Okay, fine.
All right.
Okay. Thank you, sir. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of the international conference. I hope this session was informative enough. We, on the behalf of whole team, thank you for the support during the 9th version and all the previous eight versions of the conference. We will be happy to have you in the 10th version in 2025. All the presenters will be getting a digital certificate through email within the 2 working days. Further, all the papers have already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICICT. I also thank our session chair, Dr. Sunil Kale sir, for chairing this session. This is a token of appreciation to the chair on behalf of the team of ICICT 2024 and Global Research Foundation and partners. Thank you, sir. And I kindly request everyone to
Thank you,
please.
madam.
Thank you, sir. And I kindly request everyone to please switch on their cameras so that we can have a quick snapshot. Can everyone please switch on their cameras for the picture? Okay, thank you everyone. Thanks for joining. Have a good day.
Yes, thanks all.
Have a great day. Bye.
Yeah, thank you. Bye.
Goodbye.
Yes, well, I'm leaving now.
Yes, sir.
Thanks.
Thank you, sir.